A linked list is a linear data structure used to store a collection of elements called nodes. Unlike arrays, elements in a linked list are not stored in contiguous memory locations. Instead, each node contains two main parts: data, the actual value stored, and a pointer, or link, which holds the address of the next node in the sequence. Because of this structure, a linked list forms a chain-like connection between nodes. The first node is called the head, and the last node points to null, indicating the end of the list. Arrays have limitations such as fixed size and costly insertions or deletions. Linked lists overcome many of these issues. There are several types of linked lists. First, the singly linked list, where each node points only to the next, allowing one-directional traversal. Next, the doubly linked list, where each node has two pointers, one to the previous node and one to the next, enabling both forward and backward traversal. Finally, the circular linked list, where the last node points back to the first, creating a continuous cycle with no null pointer. Basic operations include traversal, visiting each node, insertion, adding nodes at various positions, deletion, removing nodes, searching for specific elements, and updating node data. Advantages include dynamic size, efficient insertion and deletion, and no memory wastage. They are also useful for complex data structures. However, disadvantages include extra memory for pointers, slower access compared to arrays, no random access, and a more complex implementation. Fundamental concepts involve crucial pointer handling, dynamic memory allocation, and sequential access starting from the head. Losing the head pointer means losing access to the entire list. Linked lists are widely used in real-world computing systems for applications like stack and queue implementations, dynamic memory management, and even browser history. Imagine a treasure hunt where each clue gives you the next location, and you cannot skip directly to the end. You must follow clues one by one. That's exactly how a linked list works. A linked list is a powerful and flexible data structure that allows efficient memory usage and dynamic operations. Understanding linked lists builds a strong foundation for advanced data structures. In short, linked list equals dynamic memory, nodes, pointers, and flexibility. Just tell me if you'd like simple C/C++ code, a dry run with diagrams, or a comparison with stacks and queues next.